All right, so just while I'm still kind of processing your homework, what I thought I'd do is go through a programming exercise, which I'm going to basically ask you to do using a slightly different formula, and that'll be basically your homework in the interim. And so what I wanted to do was do this in Python. So a key deal here with Python is trying to, or any programming for that matter, is work out what is the problem and how are you going to solve it. And so in this case, what the problem is we want to know how much money we will have if we invest a certain amount of money over a certain period of time. And of course, have an interest, assuming there is interest, have that interest accumulating. So it's your typical compound interest formula. And I know for me, when I was going to college, I actually, as part of the mandatory classes, you know how you usually get things like accounting or you get economics, stuff like that. We also had financial math. And so I really love the idea that we actually got to do financial math. I don't see it in my office here, but I still think I have my calculator that basically does all this. And you'll be happy to know Python actually has easier ways to do this too. But for now, this is going to be basically a basic sequence is what this will be. And this is the formula for it. All right, so how would you code this? Well, first, what you would do is you'd really consider drawing it out. And that's what I'm going to ask you to do. You're going to go to the free tool here. And anyway, okay. And so what we basically have to find out is how much money are we putting in? So what's our principal? That's basically how much you start with. What's our interest rate? How many times the interest rate applied, and how long is it going to be applied? How many time periods? And so what I'll do here is I will put those just for my own benefit over here. All right. It's already starting to mess up, but that's okay. Just so I can see what's going on. I'm going to delete this in a minute, but I just want to see what that is. Now, what I'm going to do is I'm going to start, and then I'm going to pause the video, do a little bit more, unpause, and so on, so until we're finished. So you don't have to deal with the excitement of watching me do the entire diagram. But all of these diagrams, they have a start and they have an end. And so in here, start. Y'all will have a start to the sequence, and they will have an end to the sequence. And let's just move it down there. Okay, it's going to be, I'm going to need much more space than that, but that's what we got. All right, and so the first thing is, it's going to be a bunch of input statements, right? So we go through, not so much here, but in the flow charts, you'll see that there's a whole section there for input, manual input. Now, I think there's that one, or I think the book will use the parallelogram, and I'm trying to think, is the parallelogram here? No, I don't know if I can see it with the parallelogram up here. It was up there. So I tell you what, you know what? I get it. I get why Sam and Steve did that. I mean, back when I was going to school, that would have been the diagram choice, or the one I would have used for the flow chart, but there it is. So we're going to use this because this again also means input and output. So I'm going to say at this point, you know, what is the principal? And of course, the assumption is I'm going to be entering them in. So I don't have to say enter the principal. I mean, it's input, right? So I tell you what, you know what though? Let's do that. I/P is basically input. Input principal. And let's put them all on the same line. Why not? Input rate, which is what that R is. Rate, not rage, rate. Input the number. Yeah, might want to spell it out more, but that's fine. And input the periods. Good deal. So that's my input. And what I'm going to be doing is I'm going to produce out of that. We're going to produce. And this one I'll be more specific. I'm going to go print the amount that's going to come out of that. Print the amount. Basically going to say print the final amount. Good deal. And so now the middle thing is going to be a process. And that process is going to be calculate, still wrong, calculate amount. Cool. And then you connect them. So connect, and then stop, and then connect, and then connect, and then connect. All right. Now, some of you guys have been programming for a long time, so maybe you don't think you need this. I get it, but some of you haven't. And so you do need to think like a diagram. What is the solution to this problem? All right, so once I got that going, in theory, I could write some pseudocode, you know, like enter principal, enter rate, enter periods, enter number. I could write the pseudocode behind this formula, which will be a lot of fun. I won't write it, but it'd be a lot of fun to talk it through. Like, for example, what do you do first, right? So what I'd probably do is I take the R, I take the rate and divide it by the number, and then add it to the 1. And then I would take that whole thing and actually, I guess I'd have to work out that too. So basically work out what that is, and then bring this to the power of that, multiply that by P, and then at that point I got myself the amount. That's probably what I would do. All right, so I got myself my little diagram here. Let's bring up idle. Oh, and let's shut down some of the stuff that I don't need to think about anymore. So there's idle. Moving it over here. This is just the shell. I'm not going to start coding in the shell, right? What I'm going to do is I'm going to create myself a program. So there's my program right there. And so, input. What is my input? Well, let's do this. Actually, can I get that code? So I can get that code. So you know what I do? I'm going to copy that out, go back into my little programming there, and I'm just going to go paste, and I'm going to comment them all out at this point. What I'm trying to do is I'm basically planning, right? I'm planning here. I'm going to do this, calculate the amount. I'm going to put it in my code here. This is going to be my processing. Which is that. And then I'm going to do my output. Awesome. I've got a program already. In fact, by the way, if I wanted to, I could run it right now, and I'll just call this thing, you know, calc amount, and it'll run and predictably not do anything. All right, so that was really exciting. So let's actually get some stuff going on here. So each of these guys is going to be a variable, right? And thankfully, we kind of have a nice little bit right there. We could actually take this thing right out of Google and actually create a little document out of that. So what I could do is I could do this, right? Wouldn't that be kind of cool if I kind of cheat here and actually create variables? Now, you know what I don't like though about this is that I don't like letters and stuff. But I would never want to have a variable called NRP and so on. And plus, they aren't very Pythonic. We're not really specifying what these things are or what they mean or what data type they are. So, you know what? That sounded good, but I don't think I want to do that. I tell you, here's what I'm going to do. I am going to create one right away, which I'm going to call amount. And amount is going to be a float amount. And I'm going to assign it to 0.0. And I'm going to leave that as the documentation. That's the final amount. I'm going to use principal, copy, and I'm going to put principal here. Principal is also going to be a float. And let's drop the lowercase for the P. Actually, no, we can keep the uppercase. So there's my principal, right? My principal is also going to be assigned 0.0. And I'm going to leave myself some documentation there saying what that is. I'm going to have a rate. And I'll call it rate, and that's also going to be a float, and that's going to be a rate, and I'm going to leave that assigned to 0.0. And I'm going to have the number. I think number probably could have been an integer, but I'm going to make it float anyway, because why not? I'm not sure. Like, what if someone, like, I don't know in finances whether you can actually submit something for a fraction of a period, but I'll do that anyway. And then T is right there. T is the number of periods. So let's go. See, we don't want to call it P for principal. I'll tell you what, I can handle this. I can handle this. I'm going to go float. Time periods there. That way I can keep the T in there. That's just what I want to do. All right, so do that and do that. So that's awesome. I've now got myself a pretty strong input section. And then why not at this point? I've already defined my variable here. So what I'm going to do is down in my output, I'm going to print it. So I'm going to go print the total amount of your investment would be, and let's use that fancy Pythonic way to do this with the parentheses and go float amount and colon, and I believe it's comma period 2F. Remember, I'm not a Python coder. I'm going to then close the parenthesis, close the quote, close the parentheses. Remember, this won't work on its own. You need to have a little F sitting in front of the string. That's basically indicating that we're going to be passing in a variable and format. And also remember, I probably want to have the $sign. Cool beans. So let's run this thing. Let's go run. It's going to want to save. I'm going to go. And it blew up. And this is good. This is why we basically run it before we start getting into the complications of the formula. Does the input and does the output actually work? So it's basically saying that FTL amount doesn't exist. It's not defined. It's saying it's angry at line 17. Sadly, we don't have any line numbers here. If you're doing this in Python anywhere, you do have line numbers, so you can pay attention. But you know what? I can kind of get the idea that that variable is not that variable. The difference is that I must have mistyped it. FTL versus FLT. So I've got faster than light versus float. So sometimes a really good strategy is to copy and paste. And that'll, because your eyes might not catch that. But anyway, so I'm going to go run. Good. The total amount of my investments are in fact 0. That does make sense. So I've done some minor unit testing of the code. I basically tested to see, will it compile cleanly, which should tell you what, by the way, if you want to see, will it compile cleanly, let's pretend I forgot my parentheses. If I run this thing now, boom, that's a compilation error, right? I mean, the syntax itself is so bad, it can't even get to the interpreter. All right, good deal. Now let's just see, am I going to get kind of a runtime error, which is what I got here well, actually not so much a runtime error. This actually worked. Let me try it again. What we had last time when I went to faster than light. So when I actually had an error and I went go, this thing made it to the interpreter, but at some point during the run, it basically said, dude, I can't do that. And I got myself a runtime error. All right. So, and now I'm beyond that. Now I've got myself a nice running program with good syntax and I guess a good input output. Now, we've declared the variables. I suppose this would probably not be the greatest Python thing to do, but you know what I'm going to do is I'm going to have a bunch of input statements down here. That's what I'm going to do. I'm going to have a bunch of input statements. And let's comment these out first and just one at a time. So this guy is assigned, and it's going to be input, and this is the principal. So I'll tell you what, why don't I just say over here, what is the initial balance? All right. And then this guy, the fleet is going to be copy, and I'm going to go paste, and I'm going to grab the what is the interest rate. And I got that. And then I'm going to take this guy. See, if you have the pseudocode, it really kind of helps you out when you're trying to slowly build your program. So what is that? By the way, it's, yeah, I'm actually doing pretty good there. And let's do this. And let's do this. And this was actually what is the number of time periods that will elapse or something like that. Basically, you know what, probably, I tell you what, let's go, how many, how about this? How many number of time periods will elapse? Why not, huh? All right. So I got that, and then how number of time periods, how many, see, that's not very, so okay, how many number of time periods will elapse? How many times will interest be applied per time period? B. All right, so we got ourselves some cool stuff. I'm going to go run it now, and what I'm just going to start getting is a bunch of questions. So what's my thing? It's going to be, let's say, $1,000. Okay, remember, this is weird. Sometimes idle just messes you up. So you know what we're going to do? When you start seeing goofy crap like that, just run it again. Maybe even shut down your shell. So I'm going to go 1,000. Now we're back. I'm going to go 5%. It's going to be applied once, and there are going to be, I'm going to put it in for 12 years. All right, something like that. Good. So I'm, again, testing my inputs. Now, you guys know from all the other times that this is actually returning a string. You can kind of sense this by going print, actually not print, but if you just say, hey, what is the flit principle? And the fact it's coming out as a string is sort of right there telling you that that's a problem, right? And actually, we kind of made our poor little program work harder because it started as a float, but then became a string. And in most languages I know, that would cause an explosion. So what we're going to do is we're going to convert these things to the data types they're supposed to be. So this guy will be a float. We're going to pass that, the result of the input function, into a float function. And a float will convert it from one data type to a float, if it can, by the way. If you stuck in, and we'll test this out, but if you stick in like a string or something like that, it's going to basically say, nope, I can't do it, and you'll get a runtime error. So let's go float. Let's go over here and go. And I'm going to go run. And so now let's test this out. $1,000, 5, interest will be applied once for 12 years. All right, good deal. Let's run it again and put in some bad data. So let's go here, let's go run. And I'm going to go, my opening balance is grant. Boom, it explodes because it can't convert the string grant into a float. One other neat little experiment to impress your friends with, I'm going to try and put in a string of $1,000. Yeah, still couldn't do it. All right, good deal. I was interested myself in how that was going to work. All right, so great. So now all I got to do is do the hard part. But I'm going to tell you as a strategy, when you're in a new environment, I almost always would spend the first bit of my time getting information into my program, spitting information out of my program. Once I knew that that actually worked and I was getting, you know, what I was expecting, then I would start to deal with the complexities of the actual program. All right. So in this case, I'm going to leave this documentation here. I'm going to say calculate the amount of a compound interest investment. And what I might want to do for my future programmers is say something like A is assigned, so basically P multiplied by 1 plus R over N. A nice way to say power, actually, if you're going to go with Python, is the double asterisks. And then notice it says NT. I would probably up here go N multiplied by T, just to make it clear that that's what's going on. All right. So I got myself a little formula. So what I'm going to start doing now is we're going to start creating variables here. And I can almost hear you going, but wait, Grant, why are you doing that? in my humble opinion, worker variables, variables that are really only going to be important for this one little tiny piece, I probably am okay if they just spontaneously pop up in the in the executable section. All right. So right now, just trust me on this one. What I want to do is I want to basically work out what is that plus 1. So what I'm going to do here is I'm going to go, I don't know, x is assigned 1 plus, and then in this case, it's the rate divided by n, and n was the number of times, right? Number of times. So it's this number here. So that's what this guy now becomes x. And so you know what? Just to communicate myself now, what I'm going to do here is I'm going to go, but now that's no longer there. That is now x. Cool. So next thing is I want to basically get this thing, right, which is n times t. So that is n. So that's the float number. So let's go y is assigned the float number multiplied by the time period. So now my formula has evolved a little bit, and people are watching this and saying, okay, this is collapsing now. So now this is x, this is y. Okay, so now what I want to do is I want to bring x to the power of y. So it's going to be z is assigned, it's going to be assigned this. Okay. And now, okay, so let's again get that going. So let's go copy and paste. And really, this is going to be, so x to the power of y. So this is z. So now it's really just going to be z, or z, as I'm Canadian. So now, at this point, I can just kind of go that the final amount, the float amount, is assigned the principal multiplied by z. All right, so I'm going to go run. And, you know, one thing I'm realizing, I'm wondering, and let me just, interest rate decimal. That's what I wanted to make sure. I wanted to make sure, is this 5% would be 0.05. Okay, that's what I wanted to verify there. So let's go back to this. And you know what we could do here is, if that's the interest rate, let's do this. Let's take that float and divide it by 100. That will ensure that it's a decimal. Interest rate is, okay. So let's run it. And let's go. All right, my initial balance is $1,000. I'm going to leave it in at 5%. Basically, for it's going to be applied once over 1 year. Awesome. That problem was because I had a lowercase z and an uppercase z. Awesome. Shut this dude down, run him again. Okay, so $1,000, 5%. We're gonna do it just yearly for 1 year. That's about right, right? That's 5%. So, right, because if it was 1%, it would be $10. If it was 100%, then I would probably get like a lot more. Okay, so for the record, by the way, this is coming after a fairly long day, but let's try this again. Let's go $1,000. The interest rate is 100. It's going to be applied once and one. Okay. Right. So the interest, so the total amount is $1,000. All right. So now I'm starting to kind of lose my mind. Let's just try this again for a second. That is the amount. Is that the amount of interest? This might be a pause, but we'll see. We'll see. Find an example in your use case, which is kind of what this is, and then run the example, and that will also kind of help you prove whether or not your system's working. I've had wonderful times in my past where I basically had to do a lot of processing, and thankfully I was given the formula and I was allowed to run it. So let's go 5,000. Okay, so here's 5,000. This guy has got 0.0, no, sorry, 5. There are 12 payments and 10 periods. All right. So roundabout now, rather than recording the whole thing again, what I just did, I'm going to pause the video, troubleshoot my program. I've obviously got, in this case, a logical error. So I'm going to figure out what my logical error is and then get back. If you want some enjoyment, you could go and figure this out yourself too and find out, hey, what logical error did Grant give? All right, so let me just pause and I'll be right back. Well, that was fun. One of the things I kind of miss about doing this in the classroom is that you guys would then get to, when I made a mistake like this, you guys would get to watch me try and sort of figure out how to sort of solve the mistake. And what I did do is I did run off and I tried to visualize and all this, and I even had I basically took this exact formula and I basically put it into idle to make sure that it did spit out this number. I went, kicking through, and then I discovered that, what? I didn't desk check my work. What was happening here is that the formula calls for 1 plus R. Here I'm going 1 times R. That's going to be different. So this should have been 1 plus R. I don't think the interest was actually 0, but it was going to be very, very, very small. And that's why the number showed up as 0. If I change this guy to plus, which is what I'm saying up here in the formula, then this should work. So let's go ahead and run it. Go. And let's move it over so we can see them both at the same time. So this is going to be 5,000. It's going to be 5. I probably should say something in here about how it's going to be the percent. But anyway, 5. And then this is going to be 12. And this is going to be 10. And that amount matches that amount. So that's pretty cool. And so now I'm pretty confident it would work. I might be tempted to try out some other stuff. Oh, look at that. Here, by the way, here's a nice little breakdown too of the whole thing. So that's cool. All right, good enough for now. So let's go back to that program. So now that is it. That is the end. So at this point, you might want to pause, try the program out, make sure it works. But what I've tried to do there is I've tried to capture sort of this diagram in code. And then the other thing you might want to do now, because you guys are smarter than this, is think, how could you make this more sort of Pythonic? Basically, reduce some of the steps. And one of the more obvious ones is that we don't really need these input statements anymore. We definitely don't need them because it's being declared right away in the processing, in the input. So let's get rid of those. You could argue this entire thing could be done at once. And this is not for the faint of heart, but I could have done something like this. The amount, okay, well, right, let's get our case going. Float amount is assigned, and then it's going to be the principal, okay, multiplied by 1 plus, and then the rate, right, R, divided by the number, paste, close the parentheses. So I've now kind of got that done, and this is all done to the power of, and I would put this in parentheses again, the number multiplied by the number of times. Now what I'm going to do is I'm going to run this. Oops, that's totally not going to work. That was the number of time period. Somehow I missed my time period there, so let's put you in there. Okay, so the way this program works is it does all this stuff, and then at the end, it overwrites it again with another assignment. So let's go run, and let's go. Let's put our little thing up here so we can see our output, what we should be getting, our use case. Let's put this guy as 5,000. Let's put this guy as 5. Let's put this guy at 12. Let's put this guy at 10. And it seems to work. So it does actually calculate it correctly. So the whole program, in theory, could be done like this. And that's not bad. It really isn't bad, because what I've done now, I've simplified it. I don't have variables popping out of nowhere, and as long as I basically put up on top of it what the formula is, and I have decently named variables, this would be a perfectly good solution file as well. Okay. Yeah, that's it. Okay, so probably what's going to follow is I'm going to give you another sort of financial thing, and I'm going to ask you to go ahead and diagram it, and then create the program for it, and then I'll give you a use case that you can use to sort of track down to test it against. All right, cool.